All right, so just some more types of functions that we shall encounter. The types of functions we encounter will range from very simple to very complex. And this one, hopefully, is a simple one that I referred to. What do we got there? This is a linear function, right? Y equals mx plus b. We've got a slope of 5, and then the b is -4. That's the Weiner stuff. So, those should be pretty quick to graph. You do by 2 points. It's a line. The b value is -4, so that's where it crosses the y-axis. Slope is 5. Like I said, you get another point however you want, but you can use the slope as rise over run. So it's a rise of 5, run of 1, and so there you go. It's a line, and you can get other information, domain, range, so forth. No big deal. Mentioned the square root one. G of x equals square root of x minus 4. You may know a little bit about that, but again, graph it on your calculator. That's fine. But the way I look at this one, it's y equals the square root of x. It's kind of, I don't know, half a parabola kind of turned over on its side is the square root of x, and then we will sometimes utilize this. So that compared to this, you got the -4 under the square root with the x. That shifts it 4 units to the right, doesn't it? And so you get the square root graph is shifted 4 units to the right. So sometimes we'll refer to that shifting, how that does. In this case, 4 units to the right, but graph it on your calculator is fine. Now, one thing I would say here, your domain and range are kind of interesting. The domain here, the x values, we have nothing less than 4, so it's 4 and bigger. 4 to infinity, or x greater than or equal to 4 is fine too. But you see also that restriction applies in here. I can't have any numbers less than 4 here. Why? Why not? If I had 3, for example, that gives me the square root of -1. And for this course anyway, we're only going to deal in real numbers. The square root of -1 is I. It's an imaginary number. And so, you can see the restriction there. You have to have something bigger, 4 or bigger. But you can see it from the graph too. And then the range, well, the range starts at, the y values start at 0, nothing below 0, so it's 0 to infinity on range. Note that. All right. And then, we'll also come across some absolute values. H of x, notice I changed letters, let that for you. That's still a function, just giving it a different name there. Any idea what that shape looks like? Well, I mean, if you find, I think we talked about absolute value before, but you can find the absolute value, go to the catalog, if nothing else, find it. But it's on the TI-83, it's under math and then num. But you can do the absolute value of 6x plus 9. And you get, it's a V shape. This one's a narrower V. V's happening right there at -1.5, but it's a V shape. So be aware of that sort of graph as well. Now, one other type of function that sometimes we will utilize, It's called a piecewise-defined function. It's defined in pieces. F of x, here's my example, f of x equals, the first piece is x plus 2 is the definition, and that's if x is less than or equal to 1. The other piece is negative 3x, and that's if x is greater than 1. And so we've defined our pieces here. For our function. What it means is, yeah, I've got two pieces. On the one hand, f of x equals x plus 2 if x is less than or equal to 1. But if x is greater than 1, it's negative 3x. That's what that means. It's just a shorthand sort of way of writing this. Okay? Now, as far as graphing is concerned, here's what the thing will look like. Because I think that's what they have you do on this particular section, is graph some of these piecewise. Well, all right, so if I just think about this graph, that's just a line, right? It's a linear, y equals x plus 2, it's a line. Slope of 1, y-intercept of 2, so just to think about what that looks like, here's what it looks like. Rise 1, run 1. That whole graph looks like that. Now, the restriction though is x is less than or equal to 1. So here's x is 1, and I only want x is less than or equal to 1, so I want this side of it, which, bring that value up. The side I want for this is this piece, starting here at this point and then backwards, because x is less than or equal to 1. This out here doesn't really count for this graph. You with me? So when I graph this function, that's all I'm going to put on it. I'm going to start, what is that point? 1, 3. At 1, 3, I'm going to start this piece of the graph, and then it goes down backwards, I guess. When you look at it, it goes through 0, 2. With me? On the other hand, f of x or y equals negative 3x, same idea. It's a line, and some of the pieces they don't necessarily have to both be lines. They could be parabolas or whatever. But in this case, we've got another line, but it's got a different slope. The slope's negative 3, and the y-intercept 0. So it goes through the whole thing would go through 0, the origin. But it's got a negative 3 slope, so down 3, run 1. So that looks like this. However, I only want the piece greater than x greater than 1. So here's 1. So that, again, translates down to that point. I don't want this part of the graph. I only want the part that's x greater than 1. So it's this part. Now, this is kind of where you have to pay attention to the inequality there. It's x greater than 1, everything greater than 1. So what that tells me is, actually, I don't even want that point at 1. So there's a little open circle. So if you see an open circle, that's why it's there. What is that, down at negative 3? So at 1, negative 3 is where I start, but I don't include that point because that's not where it equals 1. And then down. So usually on these piecewise, this is what you get. You get this kind of disjointed sort of shape. Part of the, this is the one part, and this is the other part. Sometimes you might have 3 parts. Just depends on your graph, what they give you. Is that okay? Question or concern on that?